Okay, nice to meet you. My name's Ashok Basawapatna. I recently became a professor at SUNY Old Westbury on Long Island. And so right off the bat, if you don't have a computer, you might want to sit next to someone who does. And we kind of look over their shoulder or do pair programming. Okay. And so I'm part of the Scalable game design project. That was started in the University of Colorado. That's where I did my PhD. And today we're going to talk about how to get students engaged in programming and then in computational thinking. So it's a hands-on primer to engage students in game design and simulation creation through Scalable game design. All right, so I usually start off with a general overview of our strategy. And it's kind of theoretical, but it gives you a good idea of what we're trying to accomplish. And then we'll go into specifics on each one of these things. So on the y-axis over here, we have this path from this gentle slope from games to more complex games and simulations to more complex simulations. And the idea is that we have students create games and then are able to transfer those skills to create simulations. And we start with basic games and simulations down here, and we get to more advanced and challenging simulations at the top. All right, so these are challenges on the y-axis. And on the x-axis, we have this idea of skills, which I'm not going to define right now, but it's the idea of computational thinking skills that the students achieve as they do these challenges. And the big idea behind the Scalable Game Design project is this project-first pedagogy. So it's the idea that students come in, and they've never done programming before, and we say, create your first game. And the idea is that students might not have the skills to create their first game. And so, since they don't have the skills, the challenge might exceed those skills, and they might get into a state of anxiety. So you guys might have seen this before, some of the education people. This is Csikszentmihalyi's idea of flow. But before they get into anxiety, what we want to do is we want to give them just-in-time principles. So they're motivated to make a game, and we want to give them the principles just in time to guide them into a state of flow. This is in contrast to what we usually do, which is give students a bunch of principles first. You might think of a math class, for example. I'm giving them a bunch of principles on, let's say a linear algebra class, skew matrices and scale matrices. And so I'm giving them a bunch of principles, and they're wondering, why am I doing this? What's the point of this? And then eventually, maybe years later, they take a graphics class, and suddenly these matrices come into effect, and they think, oh, that's why I was doing them, and relearn them, because now they have a motivation to do them. So what we want to do is we give them the challenge first, the motivation to make the game, right? Something that hopefully they're inherently interested in, and we could talk a little about that too. And then give them principles in terms of scaffolding just in time to guide them into a state of flow. Okay. Oh, if there's any questions throughout the whole presentation, feel free to just stop me and ask them. You don't have to wait till the end. Yeah?
When you talk about flow, does that mean it's easy? Or
no, okay. So
I'm thinking of it as a scale, anxiety, so one person was on it, and easy, and then boredom. Can you explain a little bit more about what flow means?
So if the challenge is easy, you're in a state of boredom. That's what Csikszentmihalyi says. So if I'm playing my little cousin in chess, I might be in a state of boredom because that challenge is, my skills way exceed that challenge. But if I'm playing Kasparov's chess, I might be in a state of anxiety because that challenge is way greater than my skills that I've acquired so far. And what you're trying to do is you're trying to fit a challenge that matches your skill set. So you're in this state where it's something you can accomplish, but it's a non-trivial task. Does that make sense? Cool. Good questions. Any others? All right. I'm not going to show this video right now, but what I want to say is the Scalable Game Design project. It's a huge project. And in 5 years, recently, so these are out of date, we've had 200 teachers and 15,000 students. So it's pretty big, and we're in multiple states, as you can see there on the bottom, and we're in multiple different types of communities, including tribal communities and to tech hub communities. So it's a wide range of communities we're in. And on top of that, we're focused on middle school, so 6th through 8th grade. So if you're middle school teachers, this is something you can do. But I've also done it in high school, and I've also taught classes at the undergrad level too. So if it's something that we call it low threshold, high ceiling, which means it's easy to get started, but then it has a high ceiling of what you can actually teach students. Okay. And the final thing, and I'll give a pitch at the end for this, is that we're looking for teachers in New York City. And so if you're at all interested in this at the end, and I'll give you my email again, and the email is also up on the link page, please email me so I can support you in any way possible. All right, so there's 3 steps to engaging students in computational thinking. So the first step is, how do we engage students with 0 prior programming experience to make their first game? And then how do we go from this gentle slope from games to simulations? So how do we transfer this knowledge that they've garnered by creating games to simulations? And then finally, and one that's important for a lot of teachers, how do we formatively and summatively assess computational thinking given these game and simulation artifacts? And we're going to actually do all of this, or hopefully get through doing all 3 of these steps today. All right, just real quickly, this is an idea of how computational thinking relates to simulation design. So we might have an idea of a question, how does a mudslide work? And we might express that idea computationally. And what the computer allows us to do is visualize this consequence of thinking and say, all right, was this a correct simulation or incorrect simulation? And then we revise the model. So we get this iterative development. And so in that sense, you might think that we're able to computationally think as we go around this circle. All right, so let's dive in. Enough theoretical stuff. So what I want you to do is I want you to go to agentcubesonline.com. And is everyone's Wi-Fi working? Okay. If someone's Wi-Fi is not working, you might just want to look over someone's shoulder or pair program with them. And what I want you to do is click on Make Your First Game, Make Your First Game, and then click on Create Your 3D Game, and then pause and minimize the video. So I'll do it too, but I'll give you a second to do that. Cubesonline.com. I can log out. Let's see what it is. Okay, so I'm here, and I can say, make your first game, and I can go to create your 3D game, and it might take a second to load. And the best browser to do this in, I'm sorry, I should have said this before, is Chrome or Safari. Anything but Internet Explorer usually works. So you might get something like this. I'm going to hit pause on this, and I'm going to hit the red X up here to get rid of this video. What that video does is it walks you through this introduction game of Frogger, and it's something you can use in your class. So it walks you step by step through this first game. And so students can just follow that and actually create their first game in Agent Cubes Online. And it's multilingual, so it's in Spanish, English, I think German, and French. So it's something that might be helpful if you wanted to just try out a unit in your classroom to see how it works. Okay, so does everyone see this right now? Is anyone not seeing this? Raise your hands.
Where did you go to get there?
Okay, so I went to Agent Cubes Online. I'll do it again. Agent Cubes Online. So up here, www.agentcubesonline. All right, and then I clicked on Make Your First Game down here. And then I clicked on Create Your 3D Game right there in the middle. Is everyone seeing that? And after you click on Create Your 3D Game, it'll open up an environment with the video. You can hit the red X to the right, top right of the video to get rid of it. That just walks you through the creation of Frogger, and it's something that you might want to use with your students, for example. All right, is everyone there? Is anyone still having trouble? Raise your hands. Nope. Okay, that's a good sign. All right. So first thing we're going to do is we're going to unlock the full version. And so we have a code for all of you to use, and it's CSNYC. And so what you do is you come over to this gear in the top right, and you say unlock full version, or it might be enter code. Some of my students were saying it was enter code. It was changed to enter code. Yeah. Okay. So enter code, and the code is CSNYC. All capitals. Did it work? All right. Good. Yeah, you should see a little green message that it's unlocked, and some of the stuff that was grayed out that you may not know about yet is suddenly not grayed out, which is exciting. Okay, anyone having trouble with that?
Yeah, I don't have a Mac, so let's see. I'm on here, but I don't know where to click to unlock it.
It should be in the top right there.
Starts to me.
Right there.
Oh,
Yeah, it's kind of in the middle. And then enter code, and then capital CSNYC. All right, so let's continue on. All right, so Agent Cubes, this is the Agent Cubes Online environment. And Agent Cubes is an agent-based, rapid game and simulation creation environment. That's just a fancy way of saying you can very quickly create games and simulations. So in-game characters are agents. So any of your in-game characters are you would call agents, and you would create agents for all your nouns of your game. And agents have shapes, which is how they look. And the first thing what I want you to do is we're going to create a mini game right now, and then we're going to create a mini simulation based off that game. And so the first thing I want you to do is I want you to go to this plus agent button in the bottom left, and it should open up this window. And I want you to type in frog, and then click on inflatable icons, animals, and pick the frog icon. It actually really doesn't matter what character you pick, but try that out. And I'll do it up here too. So hold on, sorry. So I'm going to go to this plus agent button down here, and I'm going to type in frog, and I'm going to go to animals, and here's a frog, and I'm going to click save. All right, and when you do that, you should see up here in your agents, which are your in-game characters, that we have a frog agent right off the bat. Okay? Anyone having trouble with that? Nope. All right, we'll continue on then. So what we're going to do, agents have shapes, which is how they look, but they also have behaviors, which is how they act. And as you could probably tell, agents occupy this grid space, right? So we have this grid space, which is kind of our level for the game. And so what I want you to do is I want you to click on the frog and click on this pencil tool at the top. And I want you to place the frog somewhere on the level. And after you place the frog on the level, and I've got to actually, in my, I haven't actually unlocked my game. There we go. After you've placed the frog on the level, I want you to hit save in the top left. So all save does is saves your level at the beginning state. So think of it of, I put in 25 cents into the arcade machine. This is where the level will start, right? This is the setup of all the agents on the level. And so anytime you change your level, that's what you want to change. So far we have an agent, we've picked how it looks, and we've put it in the level. Now we want to program how it might behave. And oftentimes we start with the main character of the game, and the main character is oftentimes cursor controlled or keyboard controlled. So we have these, if I select a frog here, we have these things called behaviors, which is how the frog acts. And behaviors are if-then conditionality statements. So we have an if box and we have a then box here to the right. And in the if box, we put in conditions, and in the then box, we put in action. So you can think of it, the way you might explain it to students is that, if I'm late for the bus, then I'll miss first period, right? And so it gets you introduced to the basic logic of programming through these if-then conditionality statements. And so our first rule might be, if the up key is hit, then I'll move up, for example. So if we look at the conditions, and usually when I do this with students, I have them get to that conclusion, right? I have them look at the conditions and look at the actions and try things out. But we'll do a little quicker version of it today just because of time constraints. So if you scroll down in the conditions, you can find a key condition. And what I want you to do is I want you to drag that key condition into the if box. And it defaults to A. But if you click on A, you can change it to whatever direction you want the key to be pressed. So I'm going to change it to up right now. So if key up is pressed, and I'll wait a second so people can get that. And then naturally, if key up is pressed, you might want to, actually I'll give you a few seconds to figure out the action that might go along with that. So you might want to try to drag it in, and I'll do it now. So I'm gonna move up. All right. So I drag the move action in. Did you see that? So drag the move action in, and I'm moving up. So if the key up is hit, then I move up. All right. And one more time.
What was this built in? Sorry.
Oh, what was it created in?
Yes.
Agent Cubes Online was created in JavaScript, but the Agent Cubes, like the downloaded version, is Lisp, I think. All right. So if we hit play, we can. So did you see that? I'm sorry, I'm going kind of fast on this. So I hit play in the top here, and if we hit up, we could move the frog. All right. So far, so good, right? Nothing too crazy. And so now we can duplicate this rule. So I selected the rule, and down here at the bottom, you can see that you can add a new rule, you can duplicate rules. We'll just duplicate this rule 3 times to make the frog move 4 directions. So what 4 directions might you want the frog to move? So up, down, left, and right, right? Up, right, down, and down. Let's keep down. Cool. And since we saved, I can always reset to get my frog back at the beginning, down here. So there's this reload button if you want to get back to the beginning state of the game. And if I hit play, I can move the frog around 4 directions. So within the first few minutes of class, what's nice about this is within the first few minutes of class, the students can reason out how to move the frog, go from 0 programming experience to figuring out how they have their first programming rule and their first user interaction, right, in their game. So right off the bat, we're on our way to creating a game. A few other controls that you might use. It's an actual 3D environment, so you can use this kind of pan button. You can zoom in and out, and you can pan over. And you can create worksheets of varying lengths, so levels of varying lengths. And you can actually add more layers. So in the Z dimension, you can add layers to this and actually create true 3D worlds. But we're not going to do any of that. But we can always talk about that afterwards and see how you might integrate that into your classroom too. So far, we have this frog, right? And so now we're going to add bad guys to our game and kind of complete the basic game notion. And so what we're going to do is we're going to come down here to create another agent, and we're going to create a bad guy agent. So I'll let you pick what that bad guy agent might look like. I'm going to pick, so I'm going to call it bad guy. I think there's a zombie-looking person in these inflatable icons, so I'm going to pick the zombie-looking person. His name's Billy. So I've got Billy selected, and I'm going to hit save. Okay. And then I'm going to place Billy, so I'm going to use so I got Billy right there, and I'm going to place Billy, in varying places around the worksheet. And I'll hit save after that. So save. So I save the worksheet at its beginning state, right? This is where we want the game to begin at. All right. And so now we've got a bad guy, and we want to program the bad guy now. And we'll do the easiest way to program the bad guy. We'll just make him move random. So over here in basic actions, there's move random, and you can make the bad guy move random one cell. And actually, I didn't hit stop, so it's playing, and so these things are already moving random. If I hit stop and reset, we have them back at the beginning.
Where was reset?
Reload is up here, so right there. But make sure you have your worksheet saved at its beginning state before you reload. Okay. Cool. And so we're on our way, and now obviously the last thing we have is to have some sort of interaction between the bad guy and our protagonist. Oh yeah.
Random, is there a rule that when you pick the random, did you have an if something, if starts?
You could. So right now we don't have anything, but usually what you would do is you would say something like maybe once every 0.5 seconds move random. So that it would be like, and then you could talk to the students about what does 0.5 seconds, once every 0.5 seconds mean in terms of how fast it's going to move. What does once every 2 seconds mean in terms of how fast it's going to move. And so, yeah, good question. And so, yeah, now you can kind of control how fast it moves based on that once every. Okay, so now the final thing. So does everyone have that so far? Anyone having trouble with that? Any questions in general? No? Okay, good. So then the final thing we'd want to do is we want to make some sort of interaction between the bad guy and the frog. Okay? So if we go back to the frog rules and we add one more rule to it, and there's a priority implied in these rules, so we usually put the rule where the bad guy gets the frog at the very top, because otherwise if you're hitting an arrow key, it'll run the arrow keys before it runs that rule, because it goes from top to bottom. So if you make a new rule, so I went down here and I made a new rule, and I just dragged that rule to the top, and we might want to do something where the bad guy interacts with the frog. So I'm going to give you maybe a minute to try to figure out some sort of interaction between the two, and then I'll show you what I did. Yeah, question?
I just have a specific question.
Yeah, good.
So like when I click to add a new agent and I click on it, it doesn't change at all over here. It doesn't, and I can't put any new thing in it.
So sometimes that happens. You might have to reload. If you reload agent cubes, it won't lose your project, and usually those will start appearing. This just seems, that it can't get it's not loading the shape. And does that always happen to you?
Well, that just so far this time. Is that because of the?
Yeah. So.
Yeah.
And you're not using Explorer, are you?
And then you make it bad guy and pick whatever you
Oh
want.
yeah, save the game by free account. You might want to
And
do
you hit
that.
that bad guy, and it can be
Well,
anything.
I think it'll save your game.
It doesn't matter. I can do it really fast.
Awesome. Those are
Okay, so
evil.
available. Maybe you're not connected to the internet anymore.
Okay.
Okay, it has to be
Yeah, I might kick you off.
15 Sundays.
All right. Did anyone have an idea of what to do? What? Oh, to create an interaction between the zombie and the.
Oh, so if touching, then blah blah blah.
Something like that, right?
We'll have that.
Is it stacked?
Stack could work.
Stacked. Can you do the above or?
So if I'm the frog, if I'm doing it in the frog rules, which one is it? If I'm the frog would be above. If it was above, so if you moved on top of a zombie, so there's all these different things. Yeah, so you could do that. You could do if you're immediately below, if the zombie jumped on top of you, so caught you. Or you could do above and below, like you're just avoiding the zombies in general, right?
If they move to me, they got on top of me. If I move to them, they got on top of them.
Yep, exactly right.
Did you tell me your process of time?
Okay. Then play an explosion sound.
Yeah. Obviously, right? Okay, so I'll do this too. So I'm gonna use, so you can use stack. I'm gonna use next to. So next to, stack might be better because it actually jumps on top of you. Next to just means if it's in any one of the 8 grid spaces around me, something happens. And so I'm gonna say if I'm next to greater or equal to one of these bad guys, then I'm gonna do the easy thing, which is erase myself and maybe reload the world. Or maybe I'll just reload the world. That's probably the easiest. So if you come down to the bottom, you can say something like reload world. It's one of the actions. And so if I'm next to a zombie, I reload the world and the game starts again, right? It's like, oh, you just died, and we're going to start right back up again. Yeah, so you come down here and you go plus rule. And then you can you drag the rule up. All right. Anyone else have any issues?
So my music is not stopping.
Yes, because that's the rule you have there, right? If one's stacked on top of the other, and it's keep on being stacked there. Usually, what you might do is you might stop the simulation at some point, or wait a second. So there's a wait there, so you might wait 1 second to hear the sound and then stop the simulation.
So I have to make a new rule to tell it to stop.
No, in that same rule, you can put as many conditions and actions as you want in one rule. So you could say like play the sound, wait 1 second, stop, and those are all actions that can happen.
But you want to stop so you can let the player see where they were and hear the sound before you reload the world.
Yeah, so you can do, and you can wait too. So you can have a wait. There's a wait for a second before you reload them.
So they can hear during the wait second. Can they hear the?
They should be able to.
Like, will it play at the same time those sounds?
Yeah. So you could do. Let's try it. And I think wait works. There was a problem with wait earlier, but I think it works now. So let's do this. So I'm gonna play sound. I'm gonna wait. Before that, I'm gonna wait a second. I'm gonna play sound, and then I'm gonna reload world. I think that works. Or maybe stop simulation. Let's just stop the simulation so you could see where you died. All right. So I'm a frog. I'm coming around, and then it stopped the simulation right there. So did you see how that happened? So I did a wait 1 second, play sound, stop simulation.
I did stop simulation first, then wait 1 second, or then play sound, then wait. So that you're hearing the sound while
The simulation stopped.
Yeah, or also while you're waiting.
Did it work?
We're trying now.
Okay.
I lost my world.
Yeah.
Cool. Perfect.
When it was 0, I lost my world.
Oh, really?
Yeah, so stop simulation, play sound, wait, then reload world.
Maybe one.
All right. So far we've created. Or do you guys need a few more seconds to finish up the game part of it?
So it's if then, and then what's the then for when they're next to each other?
Oh, so the then for when, so if I'm next to greater or equal to 1 zombies, then I do something that says you lost the game, basically. Yeah. So that's something we haven't covered yet. But you can have many conditions, right? So if I have many conditions and an if statement, that means all those conditions must be met before I do the action. And if I have many actions, that means each one of those actions will be completed. Okay? All right. So we'll continue on. It sounds like everyone's caught up.
And then there's that thing to make it stop.
Yeah. So you want to put a stop simulation, right? Because you're going to be at the end state for a while. So we've made the beginnings of a game, right? I mean, really, if we wanted to make a game, there should be some sort of goal. So maybe we would put some sort of goal at the very top, right? That the frog would have to navigate to and avoid the zombies for. But that would be basically the same thing too, right? If you're stacked somewhere on top of the goal, or if you're next to the goal, play some hallelujah sound and go to level 2 or something like that, which is something you can do. It's one of the actions you can do. So we made a game, and that's exciting. It was a very simple game, but we're on our way to programming. But yes.
Is there a way to save it somewhere and then retrieve it?
Yes, I'm so sorry. I should have brought that up. Thank you for asking that. If you come up here and say submit your game, it'll give you this dialog box, and you come up with a username. You create a free account, so you come up with a username. I've come up with 1 million of them already, so they're probably kind of angry at me, but I can be like password, right? Email, your email address, your project name, and then if you submit it, it'll give you an Agent Cubes account, and then all your games will be in that Agent Cubes online account.
Is there a way for a teacher to see what students are making?
Yes, there is. So I can log in. So let me log in real quickly. So I encourage you to do that right now, because we're going to jump to another game. I'm going to log in real quickly. Okay, so if I'm in Agent Cubes Online, I can actually look through all the different projects that students have made. And you can do a lot of cool things here. So one thing you can do is you can click on a project, for example. So I think this one looks cool. It's like a Pac-Man game one of the students made 16 hours ago. And I can go to edit. So I can make comments on their games and give them feedback. And so you can have classes give feedback to other people's games as part of their assignments. And another cool thing I can do is I can open it up, I can play their game, I can look at their programming rules, right, and see what they did. And then I can there's this button up here called clone. And if I clone it, you're about to clone this project. It asks me to enter a quick description of the clone. I'm going to say Pac-Man game, student made. And I'm going to hit OK. And now I've cloned it and it's in my account. And since it's in my account, I can add rules to it. I can change agents in it. I can remix the game. So that's a really cool feature too, that you can do. And sometimes teachers come up with a baseline game, right? So they don't want the students to program everything from scratch. Have the students clone that and then be able to modify it for their purposes. All right. Cool. So,
I have a question.
yes.
Just on like the specifics, like how do we get access to our students' games? Is it that they're signing up under like one code?
Yeah, so right now, what you would probably do is you'd come up with a naming convention, or you would know their usernames and be able to find them. And so maybe if your students all had like the beginnings, the same username, like maybe the name of your class or the name of your school _ their name, it would be the easiest way to find it. Later on, we should be able to organize you into classrooms.
Do you have teacher accounts where you can make, where as a teacher you can make student accounts for your students, or no?
So on the old arcade we did, and I think that arcade is still up and running, and so we could do that. But on this is kind of the new arcade. This I don't know yet. I can find out though.
Maybe
Yeah.
you're gonna. Sorry.
That's it.
Go ahead. I'm just giving that a thought. Maybe you're gonna touch on this. There's a subscribe button, so there's a cost associated with it. What are the financials of this?
Yeah. So for you, nothing. So as long as we're trying to bring this into the New York City region, and so what we want to do is we want to offer for free and offer it to your students for free, and it'll be part of the research for scalable game design. But it's also commercially available for users at home, for example, who want to use it, and in those cases they would pay, some sort of fee, subscription fee, maybe like $5 a month. And I don't even know if those financials are worked out yet to access it. Yeah, question.
Is there a way to print out like a lexicon of terms so students would, like real true beginners would be able to understand what the logic words mean?
You're talking about the conditions and actions?
Yeah.
So one cool thing is if I click on a condition, usually a tooltip comes up. So you get a tooltip that says, do I see an agent with some shape to the right? You can also click on help at the bottom. So if I select a given condition, I can click on help and it comes up with help the C condition, and it will give you a whole wiki about what it's doing. So the students can kind of explore that way.
But if you wanted to have like a little menu that they can have next to the computer or like in their binders or whatever,
Yeah.
just make it yourself.
Or have the kids make it.
Yeah.
The kids make it. Yeah.
What was the thing you showed before that? What did you click on over there on the left before that?
Over here?
Yeah.
So I clicked on, let's say the kid was like, oh, what does a C condition do? And I want to see examples of the C condition.
Yeah.
If you click on it, you get a tooltip, but then you can also hover down to the bottom here.
How did you get the tooltip?
You just hover over it in the right way. It takes a second, but it comes up. And then you can also hit the help down here to get a wiki link to all the help page on that. Good questions. Are there any other stuff? Yeah.
Is there a way to delete a game? Because I can have two versions of mine.
Of your new game. I mean, we can call the admin and delete the game. But I don't know if there's any way to delete like the game you personally have. Yeah, could be good.
So how would you compare this with something like Scratch, right? So before you have, kids really going to JavaScript, let's say hands-on, there's a couple of, pre-created environments you could choose. So this is a great one. Scratch it's not 3D. But you have to sort of commit to one. So how do you see, well, in the sense that you're choosing this one versus Scratch, or possibly running with both, how would you compare this with something like Scratch?
It's a good question. So I guess I'm more interested in how would you compare something like this to Scratch, because I have some ideas, but I think I'd be more interested to hear your ideas before I shared mine.
At first glance,
Yeah.
it's a little more complex. So on the younger beginner side, Scratch is a little has that simpler drag and drop. Obviously, when you come up to speed on this environment, you know it well. It looks like there's a lot of pretty powerful stuff you can do.
Right.
So this seems a little bit up the learning curve.
Right. So I don't think it's an either or thing. Like, I think Scratch is really awesome. And I tend to think that for this, the age group we're targeting starts at around middle school. And I wouldn't try it much before middle school. So 6th, 7th, and 8th grade. But the results we've seen in 6th, 7th, and 8th grade have been astounding. So there's that side to it. So if you're a middle school teacher, I would definitely explore this. Earlier than that, you might have to have more scaffolding, which is, I think, what you're kind of referring to. And then on the other side of it, I think that once you do get past that initial that threshold, so your kids are mature enough to be able to do this, they're going to be excited, engaged in the game creation side. And then we have this path from game creation to creating simulations that's well defined that we're about to do. And that path is something that's exciting for a lot of teachers, because they're, in addition to creating games, the students are able to go and create science simulations, and the way they create the science simulations transfers over nicely from the skills they learned in creating games. Yes?
I'm possibly just talking out loud to myself.
Yes, yes.
To be prepared. One thing I liked about Snap is that you could open up libraries as needed. And I'm remembering back in the days of RoboLab, where you could scaffold for the children by being an inventor or a creator or whatever. And so you could choose to have certain libraries available to them immediately. And oh, you need more tools? Let me give you the next.
Like an extending palette.
Yeah. And I think this is great. And I love seeing all the tools available to you right away so that we or they can navigate at our own pace. But I wonder if there is a way to like hide some of that and then make them more visible, so that maybe that first game is really, you just need a couple of tools.
Mm-hmm.
So instead of, I don't know, everyone's different. I'm just trying to think of differentiating for some kids that do get overwhelmed a little easier.
Right. I think
and
that's
like
fair.
you were saying, having a lexicon, which makes it easier, but there are people that will go at their own paces and just play with everything.
Right.
It's like Zen and the art of scalable game design, right?
Right.
So that's all. There's no way to like customize it, and then no big deal. You don't need that, but that would be an interesting feature to have.
Yeah. Yeah. Unfortunately, there's not, and that would be an interesting feature to have. So what's also, but I think you lose something if you do that. Like you maybe your the open-ended game creation activity turns into a crossword puzzle or something like that, right?
Right, or you have like step 4, like our code kind of thing, like they introduce
Right.
different ones and different tools.
Yeah.
Which is kind of lame and kind of great, equally,
Right.
depending on your audience.
Depending on the audience,
Yeah.
right, and depending on what you're trying to achieve. So yeah, that's
Thanks.
a good discovery point. Yes.
I would just, I guess, think out loud as well, and it's in terms of scaffolding, I would encourage the Scratch experience first, only because they're both free. Well, if you use this New York City school, all tools are free. But what's nice about when you're teaching Scratch, I refer a lot to the draws, and then the control draw, we have all that if analysis going on, if then. So it's really natural for a child to, they're going from the block visual and seeing how things are organized in Scratch and how the draws work, and then making that analogy to how they work in scalable game design. To open up a game immediately with an if-else, that they're going to relate right back to their visual blocks in the control draw of if-else. So I think it's really natural, and especially when you start off your lecture here with the flow of control and the frustration, I think it would be a lot easier step to go from scratch to scalable game design.
And that could be how you fashion your curriculum. Yeah, I mean, I think that's totally fair. I don't really think there's a mutual exclusivity between tools like this. What you want to do is you want to get the most effective tools possible for your students and use all of them. And if you have found an effective way to maybe start with Scratch and then go to Agent Cubes Online, that would be awesome too. Yeah. Cool. And so, yeah.
One more question. Sorry. I mean, you might get to it later, but if I want to share my game, and like, is there any way I can share with people who don't have accounts?
Yeah. So anyone can make an account, and so that's probably what they would have to do. They'd have to. So if you go to Agent Cubes Online, you can see all the games up there. Actually, I think you can share with people who don't have accounts. I'm lying.
My class does blogs, and that's how we share our work with each other. So it'd be cool if we can like post it onto our blog and just play right off the website.
Yeah, so I think you can. Like there's a way to share it on Facebook, for example, and stuff like that.
Oh,
Well,
which means you really need to be 13 or over legally to.
If you want to share it on Facebook.
And not have it be blocked because it's blocked.
Right. I mean, that was just one of the ways you can share it. That's not like it's shareable. And now the internet's slowing down. That's not fun.
Once you share, can anybody do the edit of the game? Just the way there's, in Scratch where you can remix other people's games?
Yeah. So that was the thing I just did. I cloned.
When you clone is the same as remix, but don't you have to have somebody's, in Scratch you don't have to have somebody's username. Like you can go to any random.
I can go to any random one here.
Okay.
Cool. I just looked at the terms of service for this, and it says you have to be 13 or have a parent's permission. So it might be a tough sell to just suggest to use it in middle school for middle school teachers.
You have to be the terms of service for
agentsonline.com. Yeah.
Oh, really?
So you need to be at least 13 years old or be represented by a parent to register for it. So whatever. You
That's a good point.
position.
Yeah.
I get it.
But you can look at Autodesk. What they do is they have a teacher. So a teacher can assume the responsibility in the
Right.
classroom. But it is something that they've set up that you download in teacher
So you
sites.
get a permission slip.
Oh, so if they have that, like a teacher
kind
would
of
still have to
frees
give a
everybody
permission
up.
slip for that?
It depends on the community, or how strict people are and how much people
Interesting.
want to be compliant. But I recommend being compliant when it comes to things like this
Right.
for sure. So just when you're saying to people, oh, this is great for middle school, forgive me, I'm sorry, but maybe remind them, in the terms of service, you do have to be 13.
You do have to be 13.
So make sure that is communicated with your
Right.
schools. and
In case they're
parents and
not
teachers.
13, they might have to do whatever they need to do to be compliant.
I love the rules.
Okay. Yeah. So this is something I didn't know. So this is good to know before I start spreading wrong information. All right. Cool. Less than that. So we'll do a quick simulation. I think we'll end with a quick simulation, just so that you guys can see how that transfer works. And then I can answer any questions afterwards too. But these were all great questions, so I was really excited to answer these. So we'll jettison the presentation for now, and we'll create another 3D game. So let's create. So if you've already logged in, you can create a new game. You can go to new project. Since most of you have probably created a login already. If you haven't created a login, go to the top right and hit submit your game and create a login, so that you save your last game. And then we'll go to new project. And I'm going to name this project Forest Fire. Forest_fire. They don't allow spaces in the names. I'm going to hit create project. And so one thing you might be wondering is, when we created that game, I've been saying, we've been learning computational thinking skills, right? But I haven't made those explicit yet. The way we make those explicit in the Scalable Game Design Project is by referring to them as computational thinking patterns, and explicitly teaching them to students. So they're abstractions students learn in programming activities that transfer to other game and simulation creation activities. And so you might think of collision patterns, for example. Like, we programmed a collision pattern just then. When two agents come together and something occurs. In this case, it was an absorb. An agent disappears when in contact with another agent. We could also program a change, right? An agent changes when in contact with another agent. And they're a way to make computational thinking skills explicit. And also a way you can use to assess students' games, especially if they're open-ended games, what computational thinking patterns existed in these games. So this is just to make it a little more clear. One of the computational thinking patterns is tracking. That's a ghost tracking Pac-Man. In the real world, we might have a predator tracking a prey. And in the simulation world, we might create a predator tracking the prey. So we might create something in the game world and learn some skills from that. And this is a way to try to make what skills they're learning explicit when they transfer it over into the simulation world. So there's some other ones, and we can look at these later. And you might think of them as, we could just have two generic things acting out these patterns. And so let's say we did this one in the frog game we just did, right, with the zombie making the frog disappear. So one generic agent came to another generic agent and made it disappear. It didn't matter what they were. But now we can think of it in different contexts, right? We can think of it in our frog game, one agent making another agent disappear, right? And we can also think of it in maybe a predator-prey simulation. A predator coming into contact with a prey and making it disappear. So as they learn these games, what we do is we make these computational thinking patterns explicit that they learn, and then they transfer them to other games and simulations. And so as they're learning games, they're learning how to implement these patterns, and then they're able to re-implement them, hopefully, in the simulation world. And that's how we create this path from games to simulations. And so we're going to do something similar. And there's movement patterns, too, we can talk about, like tracking one agent, chasing another agent, random movements, one we did earlier, and directional movement, things you might commonly see. All right. So now we'll do kind of a quick simulation, and then we'll probably have to end in 15 minutes. But if they let us go over, we can do some more. We can make the simulation as complex as we can in the next 15 minutes. So let's start by creating an agent, and this is going to be a forest fire simulation. So we'll create an agent, and we'll call it a tree. And under plants, we'll find a pine tree. So I'll give you guys a second to catch up with that. And then I'm going to hit save. All right. So I've got this tree up here. Is everyone there? Anyone need more time? No. Cool. And so we've got a tree, and if we're doing a forest fire simulation, what shape should this tree? So we have a healthy tree. What other form should this tree possibly have? Does anyone have any ideas?
Tree on fire.
Tree on fire. All right. So let's create a tree on fire. So one thing we can do is we can go down here and we can add a shape. So we don't have to add a brand new agent. Every agent can have a different shape to it, or many different shapes that it has. And think of it as costumes you wear or forms it takes. So a tree on fire would just be a different form of the same agent. So instead of creating a new agent, we could create a new shape. And we'll call it tree on fire. Tree on fire. Okay. So we have a tree and a tree on fire. And so some of you might be wondering if you can edit these shapes. And so we'll actually edit one of these right now. There's this 3D editor. So if you double click on it, I'm sorry, let me do that again. So we have this new shape, tree on fire. We want to make it look like it's on fire. So we double click on it, and you get this kind of editor here. And in this editor, you can play with all sorts of things. You can play with the 3D shape of it. You can select parts of it and inflate it or deflate it. You can add noise and stuff. I'm going to go very simple because I'm not the artist type at all. So I'm going to make a red burning tree on fire. It looks more like blood than fire, but whatever. And I'll hit save. So that's a tree on fire. And then, so I'll wait a second for people to get there. So what I did there was I selected the flood tool, and then I selected a color I wanted, and then I clicked in there to make it flood fill. All right, and then I hit save. Is everyone kind of there? Pretty much. All right, and so now we have a tree and we have a tree on fire. And we're going to do one more shape, and that is a burnt tree. So I'm going to add the shape, and I'm going to say burnt tree. And I'm going to hit OK.
Spooky tree also looks like a burnt tree.
Oh, okay. Oh, let's just do spooky tree. So I'll make a new agent and find spooky tree. It's not ideal, but it'll be good enough. So I'll add shape. I'll say burnt. I'll say OK. And and I'll make it charred to a crisp. Where in? Red, green, blue. How do I get black? Oh, here. Okay. And I'll hit save. And now what we want to do is we want to place some trees on the level. So I'm going to place a bunch of healthy trees on the level. I'm going to place a few trees that are on fire, and I'll hit save. And what I'll also do is I'll pan it down a little so it's a little more apparent what we're looking at. And I'll hit save again. So now when I reset, it's always going to come back to here. Even if I pan, differently, I can always reset back to here. All right, so we got some trees on fire and regular trees, and we're going to come up with some rules for these. But the rules we're going to come up with, we're going to put in methods, which is the version of functions in Agent Cubes Online. So what we're going to do is we're going to, and we'll do this real quickly, and then we'll talk about it. Is we're going to say once every 0.5 seconds, we're going to pass ourselves a message. So we're in the tree behavior, and we'll pass ourselves a message. And the message we'll pass ourselves is, we'll say, we're going to call a method on ourselves, and we're going to name it make fire. So, and that's going to be the method that covers if we're a normal tree and we're next to a tree that's on fire, if we catch on fire or not. And then we're going to do another message, which is make burnt, which is the method of, okay, if I'm on fire, now I'm burnt. I'm going to become burnt with some % chance. Okay? And so we're going to come down here and we're going to add a method. So is everyone kind of there? So these two messages, make fire, make burnt, and once every over here in the conditions. So once every 0.5 seconds, we're going to make fire and make burnt. Then we're going to add a new method, and this method's going to be called make fire, right? So we're calling make fire, and we're going to put this method down here, make fire. And it's going to say, if I see myself as a healthy tree, and I'm next to more than one burnt trees. So this is similar to the zombie pattern we just created. More than one trees on fire, I mean. So more than one trees on fire, then with some % chance, I'm going to catch on fire. So we'll make it 50% chance. So if I see myself as a regular tree and I'm next to more than one burnt tree, I change myself to I'm gonna with a 50% chance catch on fire, right? So I'll change myself to a tree on fire. And so myself is always just this dot, right? It's no arrow pointing nowhere, means myself in Agent Cubes. So that's the rule. If I see myself as a regular tree and I'm next to more than one burnt or one or more burnt trees, there's a 50% chance I changed into a tree on fire. Or more than one tree on fire, I'm sorry. There's a 50% chance I changed myself into a tree on fire. And then the final rule in this simulation, the final method we're going to add, so we're going to add one more method down here. And the final method we're going to add is going to say, if I see myself as a tree on fire now, and there's a 50% chance I'm going to change into a burnt tree. So I change myself into a burnt tree. That's a regular tree. This is more of a burnt tree. All right? And that's it. So that's our simulation, or that's the rules for our simulation. And so I'm going to hit play here and see how it works. Make burnt. I forgot to change it to make burnt. So we have make fire, make burnt, and we're calling make fire and make burnt. And we just have 3 rules in this whole simulation. So if I hit play, we can see that, oh nice, we can see the forest fire spreading throughout the forest. We can actually plot this in agent cubes. I don't have time to show you. Actually, I do. I made the simulation before. So I can show you in the pre-made simulation. It'll be like a cooking show. Well, it's taking its time. So while it's taking its time, so you can run it multiple times. You can run it with different densities. All right. So fun for a game of life. Forest fire. So if I edit this one, so I made another level on this, and I added graphing capabilities just to show you, but we're not going to have time to actually go over it. So I made this big level because it's kind of just more fun, and I'm graphing the results too, and you can see the forest fire spread across the level, right? And you can see I just graphed the number of trees still available, and so you can kind of I don't know if you saw it up there, but it kind of spread through the top, and we can try it again. And so you can have students, so that one burnt out really quickly, we can try it again. That one then burnt out pretty quickly again. And then this one's kind of gaining some speed and doing a bunch of, going through a bunch of these.
What's on the x-axis and what's on the y-axis?
So the x-axis is time, and the y-axis is the number of trees. I'm just doing the population.
Number of live trees.
The number of live trees. And you can graph many things. So I could have 3 graphs going on there. Number of burning trees, number of live trees, number of burnt trees. You could do all that too. It's all the same in the same graph. And you can actually export it to Excel if you want to. So that's something you can do with students to further explore the data. All right. So if you think about this, so we've made a pretty quick simulation. It was based on that quick game we made, right? The main interaction is the interaction we had in the game, which was when I'm next to this zombie, I do something, right? And here in the forest fire, it's the same type of interaction. And if we made an epidemiology simulation, it would almost be the same thing, except you might think of randomly moving trees, right? And trees on fire being the ones that are sick, right, and the burnt trees being the dead humans. The one thing an epidemiology simulation, or a disease spreading simulation, I should say, would be different from this is that, some of the trees on fire would be able to become healthy trees again, right? And that would be the one thing you might add. But then you could graph those populations too, just like we're graphing the tree populations right now. And that's really simple to do. Other things, yeah?
In this simulation, you chose to have a tree on fire and a burnt. Can you have multiple levels so that, for example, you have something that's 25% on fire, then 50%
I love
on
it.
fire,
Yeah.
then 75%, or something of that sort,
Yeah.
so that you could change the probability each time depending on how, like the first time you had a 50% probability,
Yeah.
and then after
Right.
lower the probability the first time
Yeah.
25% to get
Right.
to 25% on fire, then
Let's do it right now. So let's do. You can do it. So you could do a lot of things. You could have. Oh, are we almost done?
Yeah, we got like a minute left.
Okay. So this is the last thing I'll do.
Okay.
So and you see the percent chance down here? We can do like a global variable called chance on fire, for example. And then I can grab something called simulation properties and add this global variable chance on fire. And so instead of 50% chance of getting on fire, we have it up here, and we could change that probability for the trees. And then you could have attributes for just a single tree too. So they're called agent attributes. And you could define so you could have all these different types of trees. This is a redwood tree's chances of getting on fire. This is a pine tree's chances of getting on fire. And so you can do that too. And this is actually, yeah.
That variable that you created, chance of can you put a range and have a random, like can you make it into an array and have a group of numbers?
You can make it random.
You can make it random.
Yeah.
You can't define the range of
You can
random?
you can define the range of random.
You can
Yeah,
define
yeah.
the range. Okay.
Yeah. And I think that's just random.
And then you put the upper and lower in the range.
Yeah, you could put the. So I think it gives you one from 0 to 1, and then you can just put an equation into that percent chance thing.
Okay.
So you could put like random. I think it's random. I think that's the keyword, and I think it assumes 1, and then you could be something like 50 times or something like that. I forget the exact.
Okay.
Or whatever.
It's probably somewhere in the back.
Yeah, it's probably somewhere in the hope. If I go to percent chance, maybe we could see it. Cool. So I guess I'm done, right? But we can talk afterwards. And one last thing. We're working on a grant right now, or a proposal, I should say. And we're trying to find as many CSNYC teachers to try to implement simulations in their classrooms. And I want to support you any way possible. So if you're at all interested in that, please talk to me afterwards and grab my email address. Thanks again.